My name is Anna Jenkins, and I am a junior in anthropology at Purdue. I worked with Alyssa Seaman, whose poster provided the background for our 3D scanning project of individuals from the archaeological site of Tombos. My poster covers how to do the scanning and the preliminary results. The hardest part, in my opinion, was learning to scan. The spider scanner can be tricky to use as it only operates under a very specific set of conditions. In order to have the scanner at peak performance, it has to be warmed up to at least 52 degrees Celsius. We also noticed that it was easier to keep tracking the scans it was making when it had recently been recalibrated. With each calibration, you had to be exactly on the line of every position, or else the entire calibration would be drastically off since the scanner scans to the nanometer. Once the scanner was at the optimal temperature and had been recalibrated, we could begin scanning. Each specimen was placed on a foam circle, which was then placed on a rotatable platform for easy and fluid coverage. Since the Artex Spider is a handheld scanner, we found it best to be sitting up straight with the scanner held high in one hand and slowly spinning the crania in the other. For full coverage, it was best to also be moving the scanner vertically as the skull was spinning horizontally. Given how the scanner orients itself, if there was too much horizontal movement, the scanner would lose tracking and would be unable to continue with that scan. One orientation had the cranium positioned so the inferior aspect as well as the superior portion of the neurocranium was scannable. And the second orientation had the cranium positioned in a way that we can scan the frontal position of the skull around the cranium to the occipital. Each scan was then examined to make sure that there were no holes in our data, that any of the areas of the scan were missing, or if the scanner was mislaid the scans on the final project on the computer. The scans were then run through a global registration process to make sure everything was aligned correctly, and that they were then ready for the landscaping program. The global registration is a process run by the Artex software that fuses individual data points into one cohesive 360-degree scan. Overall, when we first started out, one skull would take us about 2 to 3 hours, but that time was drastically reduced as we became more familiar with the process and the technology. By the end of the scanning phase, we could scan one skull with all its orientations in under an hour. However, there were some other factors at play as well, not just inexperience. Given how complex the cranium is, it was difficult to get the scanner to pick up on certain nuances and crevices of the skull itself. Since the skull is not the same shape all the way around, it makes it difficult to scan. For example, to scan the orbits, you must get the scanner close to the face so that the light can reach the back of the orbits. However, the scanner will then recognize that this is too close to the frontal bone and it will send an error message. So it can be a little tricky getting all of the details of the cranium. Some more problems that arose during our research were not having enough computer space to run the software and getting tired while holding the scanner. But once we were able to get an accurate scan, we could then use the scans to place 94 osteometric landmarks to measure the differences across the population. The landmarking software is called GUIMorph. This was developed by Dr. Autorola Castillo of the Purdue Anthropology Department. The GUIMorph program runs by allowing open source placement of the landmarks. This means they can be moved and placed by us, the researchers, instead of using a system that would place them automatically. Because of this, we can place them all more accurately and in the correct place for each skull. Once the scans have been run through the landmarking software, the next step is to determine if individuals from similar tomb types also have the same morphology. In order to do this, we have to analyze the landmarks we have overlaid on the surface, and then we use the shape coordinates to find the amount of variation between the different variables in the scans and on the crania themselves. The preliminary results for this suggest that there are significant differences in cranial morphology of individuals from different tomb types. Due to the clustering we can see in the results, we can infer that the pyramid burials of the Egyptian elite do not overlap with the tumulus burials of the Nubians, which suggests that they are morphologically different groups. However, the Egyptian middle class burials are distributed across both of these groups, showing a more heterogeneous morphology. These findings imply that the Egyptian elite were separate from the Nubian-style tumulus burials, but that the people buried in the chamber tombs were possibly the people who were interacting with the local Nubians. Social status may have played a role in how people interacted with each other, as the source of local interaction appears to have been in the middle class groups. Up until this point, we have just been doing an inventory of the collection and scanning the crania that have been deemed acceptable to continue with the project. As we scan the crania in multiple orientations, we will then go back and fuse the scans into one full 360-degree scan. Once we have learned how to fuse the scans and received a full three-dimensional rendering of the skull, then we can add the osteometric markers in order to take the measurements needed for the analysis. Our hypothesis is that the final results will mimic those of the preliminary analysis.